Hello, my name is Selena Tipton. I unfortunately cannot be at exhibition night due to the fact I have a school softball game I have to attend. My presentation is all about toxicology tests. This means the different tests that might happen within a toxicology lab. Toxicology overlook. So what is toxicology? Toxicology is the test of mainly drugs, but any substance that might be found in the field that we might suspect to be some sort of drug, or we just need to know what it is. They can test for different types of drugs, including cocaine, marijuana, methanol, and alcohol. These tests can, besides forensics, these tests can be asked for from a doctor, a school, or a new job to make sure that you're not taking drugs while at work. A doctor may ask for additional drug testing if they suspect abuse and they're dealing with mental health and they can't quite control everything. So the different types of tests I'll be talking about. One, we have mass spectrometry, which is done through a mass spectrometer. We have gas chromatography. We have microscopic, looking at the items under a microscope, and capillary electrophoresis. So mass spectrometry helps to tell you what all is in your sample. Gas chromatography separates violent substances, and I'll get into that later. Like I said, microscopic is looking at different powders under a microscope normally. And then you have capillary electrophoresis. This is looking at DNA. Mass spectrometry, or MS, is a test that helps tell you how much atom mass there is in an element. This is done with a magnet and a detector, basically. So first, this sample that you have gets vaporized, then it gets ionized. Next, the sample gets accelerated into this magnet. This magnet deflects the ionized particles down, and this helps give us how much forces and how much mass is with that certain particle. Then the detector will read those angles to tell us what they are, and we'll put it in a nice formatted chart for us. Gas chromatography. Gas chromatography is the separation of volatile compounds that are easily evaporated at room temperature. These samples get placed into the machine as a liquid. Then the substance turns into a gas, separating any different elements within that compound. Inert gas that doesn't react with either any of the substances within the main substance gets pushed into the chamber to propel the rest of the gas through a tubing. This is normally like a really long tubing that will start heating up the different components. Next, it will go through a detection part that helps tell us how many particles there were and what compound they were. Faster moving gases most likely means it has a lower boiling point. This means that I can tell the difference between two different materials, whether one of the materials is going extremely fast and the other one's going extremely slow. Smaller particles also move faster. The first hump that you'll see in the end result that you'll end up analyzing is normally just some extra stuff. It's those two bigger humps that you really want to focus on. Then a scientist will go through and read those results. So this is a picture. You have the ionized gas. Sorry, not ionized. Inert gas is the cylinder that you can see at your bottom left. And you see where you insert the sample, it'll push it through this long tube. And it's curled in that fashion so it fits within the machine. It's all heated up, goes through the detector, and then we have our data output all the way to the right. So then we have microscopic. This is just looking at the different powders and comparing it to a standard that the lab has. A standard is a substance that we already know what it is and we'll use it to compare it. This is one of the more iffy forms of knowing what something is because it's all based on how much it looks similar, and that's based off of what the scientist sees. So on the right here I have an example. So we know that the right one is weed. That was our standard that we had in the lab. So then the question is the left one weed? Or is the left one something similar to weed, but not weed itself? The answer is they're both weed, but some people might say, oh, well, that coloring's off on the left one. It can't be. Or that might just be a different form. There's different questions to ask yourself when looking at these different tests. The last one we have is the capillary electrophoresis. This helps identify fluorescent DNA. You only need a small amount of DNA for this. The DNA gets separated by these little enzymes, and they'll cut it at different spots. Electrophoresis labeled DNA samples are put into wells and then loaded into the capillary electrophoresis instrument. Then the machine puts a polymer into those wells. This polymer helps do some magic, quote unquote, and it will react with the DNA in there, moving the DNA fragments forward. In this machine, you have to have it very temperature and magnetically controlled to get the samples to move in the way you need it to. You'll have your smaller particles moving faster with your heavier particles moving slower. The last step is detection. We'll detect those rates and detect what type of DNA structure that is. This is all caught on an actual camera within the machine. Then it will be put onto the computer for a scientist to analyze. And lastly, we just have citations. I hope you enjoyed my presentation. I am again so sorry that I couldn't be there to answer any questions you had. I really like the subject of toxicology. I find it very interesting, the different tests you can do. There is a test that you can take on the table through a QR code, and then there's also a handout. The handout recaps on what I just talked about. It also has a picture of all the different machines and how they work. And then on the back you can find some of the information of how you would be tested, whether through work, school, or anything like that. Have fun researching. Thank you again.